Industrial AI only matters if it helps operators make better decisions in real time under real plant constraints without asking them to blindly trust a black box. HMX is designed for that exact environment. It brings explainable, causal reasoning into process control, so recommendations are not just accurate in theory, but understandable and usable in practice. The core value proposition is simple: safer decisions, more stable operations, and AI that shows the logic behind every recommendation. In safety critical operations, the question is never just, what should we do? The real question is, why is this happening and why is this the right action? Operators are responsible for production, safety, and asset integrity, so they cannot act on opaque model outputs. At the same time, regulators and plant leadership are placing more pressure on traceability, accountability, and defensible decision making. If an AI system cannot explain its cause and effect reasoning, it does not become operational infrastructure. It becomes a suggestion engine that people ignore. That is the failure mode of black box AI in the control room. It can detect patterns, but it often cannot distinguish between correlation and actual process causation. As the process drifts, feedstock changes, or operating conditions move outside the training norm, confidence drops and outputs become harder to trust. Worse, when an alert appears, the operator still has to do the real work of diagnosing the issue. So instead of reducing cognitive load, black box AI often adds another layer of ambiguity. In practice, that means low adoption, frequent overrides, and very little realized value. HMX solves that by combining two things that industry needs at the same time: human operational wisdom and machine scale reasoning. Human experts understand the plant, the failure modes, the SOPs, and the trade offs. Machines can monitor more signals, evaluate more interactions, and do it continuously. HMX turns that combination into a cognitive agent that reasons through plant behavior in a way that mirrors how experienced operators and engineers think. This is not about replacing people. It's about scaling the best plant knowledge and making it available exactly when a decision has to be made. This slide shows the difference between notification and decision support. A black box system says temperature anomaly detected, which tells you something is off but gives you no path to action. HMX goes further by breaking the situation into diagnosis, likely root cause, forward prediction, and recommended intervention. That is a fundamentally different operating experience. Instead of forcing the operator to interpret a vague alert, HMX frames the situation in operational terms: what is changing, what is driving it, how urgent it is, and what action is most likely to stabilize the process. That is where explainability starts translating into usable value. The reason HMX can do that is because it models the plant the way senior operators actually reason about it. It combines live sensor data with SOP logic, process physics, engineering constraints, and plant goals like stability throughput and safety. In other words, it does not just see data streams, it sees relationships. It understands that a temperature rise, a pressure change, and a valve behavior pattern are not isolated signals, but part of a connected operating story. That cognitive map is what allows HMX to deliver outputs that sound like engineering judgment instead of generic AI commentary. This architecture matters because industrial AI has to work inside real operating environments, not just analytics sandboxes. HMX ingests multiple sources of plant knowledge, including sensors, historian data, lab data, and SOPs. Inside the reasoning engine, those inputs are structured into cognitive models, Bayesian reasoning, assessors, and simulation layers that work together. The outputs are therefore actionable and traceable: diagnoses, predictive alerts, root cause visibility, and corrective recommendations. The commercial point here is important. HMX is built to become part of plant decision making, not just an external dashboard that someone glances at after the fact. Many AI vendors talk about explainability, but a lot of that is post hoc approximation. The model produces an answer first, and then another layer tries to explain it afterward. That is fragile because the explanation is not the true source of the reasoning. HMX is different because explainability is native to the decision process itself. The system reasons through a causal chain, and that same chain can be shown to the operator, engineer, or auditor. That makes the explanation more stable, more defensible, and more aligned with how industrial teams actually investigate abnormal situations. For AI to be accepted in an industrial setting, it has to meet engineering-grade requirements, not consumer software expectations. That means causal modeling instead of pattern-only prediction. It means situational awareness that identifies early precursors, not just late-stage alarms. It means simulation so teams can evaluate what-if scenarios without introducing operational risk. It also means capturing expert knowledge before it walks out the door, operating at the pace of DCS and SCADA environments, and supporting compliance requirements with clear auditability. HMX is positioned as infrastructure for industrial decision-making, not as a lightweight analytics overlay. There's a major workforce dimension to this value. Many plants are dealing with retirements, skill compression, and the loss of hard-earned operational judgment. At the same time, newer staff are being asked to manage increasingly complex systems under tighter performance and safety expectations. HMX helps preserve expert reasoning by embedding it into the system so that expertise becomes operationally reusable instead of remaining trapped in a few individuals. It also helps reduce alarm fatigue and decision overload by filtering noise and surfacing reasoning that directs attention to the real issue. That improves consistency, training, and resilience across shifts and teams. This is also where HMX becomes strategically valuable beyond the control room. Regulatory expectations are rising, and organizations need AI systems they can defend. If a recommendation contributes to an operating decision, teams need to know how it was formed, what evidence supported it, and how to investigate it later. HMX provides the chain of reasoning. That supports audit readiness, incident review, compliance workflows, and broader governance requirements under frameworks like the EU AI Act, OSHA process safety expectations, and the IEC-oriented environments. In practical terms, it gives operations, engineering, and compliance a common foundation for trust. The business case comes down to three outcomes. First, reducing unplanned downtime by identifying and resolving abnormal situations faster before they escalate into larger losses. Second, increasing energy efficiency by making process recommendations that are grounded in how the plant is actually behaving, not just statistical patterns. Third, improving operational stability so performance remains more consistent even as feedstock, conditions, or operating contexts shift. Those three levers map directly to real plant economics, fewer interruptions, lower operating costs, and more predictable output. That is how explainable AI moves from an innovation project to a value-generating operational capability. This is the adoption argument. Operators do not adopt AI because it is advanced. They adopt it because it helps them make better decisions under pressure. HMX identifies root causes instead of surfacing statistical noise. It predicts emerging upsets before they become major events and explains why those upsets are forming. Its recommendations are framed in engineering language that fits the way operators and process teams already work. And because it is built for DCS, SCADA, and mission-critical control contexts, it fits into the real operating stack instead of asking the plant to adapt to the software. That is why this is AI operators can actually use, not just admire. The message to leave with is that HMX makes industrial AI operationally trustworthy. It brings transparent reasoning into plant decision support so teams can act earlier, act with more confidence, and defend those actions when it matters. The value is not just better prediction, but better judgment at scale, safer plants, more stable operations, and preserved expertise. The natural next step is to apply HMX to a high-value use case where trust, explainability, and faster intervention can produce measurable impact quickly.